This is Blake, Brandon, and Wills, and we're doing a video over acid-base neutralization. In this first example, we have a strong acid, HCl, reacting with a strong base, NaOH. When a strong acid and a strong base react, water and a salt, in this case NaCl, are formed. Since HCl is a strong acid, it dissociates into H plus Cl minus. And since NaOH is a strong base, it dissociates into Na ions and OH ions. NaCl also dissociates, since it is soluble in water, and it forms Na plus Cl minus. Na plus and Cl minus are both spectator ions, so they are removed from the equation for the net ionic equation, which is H plus aqueous plus OH minus aqueous goes to form water. This is the net ionic equation for any strong acid and a strong base reaction.
In this second example, we have a strong acid, HNO3, and weak base, C5H5N, reacting to form the conjugate base of the strong acid, NO3-, and the conjugate acid of the weak base, HC5H5N+. HNO3 is a strong acid, so it dissociates to form H ions and NO3- ions. C5H5N is a weak base, so it does not dissociate, and HC5H5N+ is a weak acid, so it does not dissociate either. NO3- is a spectator ion, so it is removed from the net ionic equation, which is H plus C5H5N, going to form HC5H5N+. The net ionic equation of any strong acid-weak base reaction is H plus the weak base forming the conjugate acid of the weak base.
In the last example, we have a strong base, NaOH, reacting with a weak acid, HF, which forms water and the conjugate base of the weak acid. The NaOH is a strong base, so it dissociates to form Na plus and OH minus. NaF is soluble in water, so it dissociates into Na plus and F minus. Na plus is a spectator ion, so it is not included in the net ionic equation. The net ionic equation is HF plus OH minus yields water and F minus. The net ionic equation for any strong base weak acid reaction is the weak acid plus OH minus yields water and the conjugate base of the weak acid.